you think is the most absorbent and which do you think is the least absorbent?
I'd say least for the first one. Probably most.
I believe in
I'd
you.
probably say this one.
Is the most absorbent?
Yeah,
And what do you think is the least absorbent?
probably the school one.
And even pranked.
This one?
Most absorbent?
Yeah.
And what do you think is the least absorbent?
Probably the organic one.
The natural are the most absorbent. Oh my god, these Playtex sports ones are tiny. I think these are the least absorbent ones. What?
First person to get it right. Give me some. Millions of women use tampons every day, and there are so many types of tampons out there. We chose this experiment to understand how tampons absorb blood and how different structures and shapes affect absorbency. The main ingredient in tampons is cotton, which is made up of cellulose. Cellulose is made of a long chain of glucose molecules. Glucose molecules are polar, as are water molecules. This polarity causes the two molecules to be attracted to each other, and because menstrual blood is made mostly of water, it is attracted to the glucose, which helps the cotton in the tampons absorb the menstrual blood. To begin the experiment, we came up with a recipe for a fake menstrual blood for the tampons to absorb. To make the blood, we used water, myoglobin obtained from raw steak, gelatin, and food coloring to imitate properties of real blood like consistency and color. Next, we weighed each tampon and put them in separate beakers. We tested 4 tampons per brand for a total of 20 tampons. Then we measured out 100 milliliters of blood for each tampon and poured it over the tampons in the beakers. We left the tampons to soak for 3 hours. After 3 hours, the tampons had expanded, and we weighed each tampon again to compare it to the weight from before absorption. Our results show that natural tampons absorb the most at an average of over 11 grams of blood, which is more than 1,000% of the starting weight of a natural tampon. From this experiment, we learned that the shape of tampons likely has a major effect on absorbency because each tampon has a unique shape. We made a connection to molecules whose shape also affects things like chemical properties. If we were to do this experiment again, we would design a test so that the tampons could absorb while in a vertical position instead of horizontal, which would give more realistic and unbiased results. Overall, this experiment led us to think about how useful science is, because its absorbent properties allow tampons to be worn by women everywhere.